If you're new to CNC, you probably haven't heard of Datums before, but they're essential for being able to position jobs on SmartBench. And you do that quite a lot. You might want to put a new job in a different part of the material, or you might have swapped out your stock material. So Datums make repositioning job files really quick and easy. In this series, we're going to talk about the theory of Datums, how to position a datum on a job file, how to position a datum in SmartBench, and then finally some strategy on which datums to use for which applications. Let's start by talking about what a datum actually is. A datum is simply a point in 3D space, and you get to choose where that point is. Now, because it's only a reference point, that'll be quite difficult for me to illustrate in this video. So I'm going to use this large target symbol as a pointer. You wouldn't normally see this, it's just for me to show you where a datum is. And in this example, hopefully you can see that I'm trying to point to a datum which is positioned on the top corner of a block. So here's how it works. Every job file has its own datum, which is set when it's created in the CAD/CAM software. SmartBench also has its own separate datum, which we call the working datum. And this working datum can be moved around the SmartBench's available workspace. When SmartBench loads a job file, it will align the job file's datum to SmartBench's own working datum. And that's how a job file is positioned. And when the working datum is repositioned, the job file is simply repositioned with it. So we've got a datum in the job file and we've got a datum in SmartBench. Let's start by having a look at a datum in a job file. To illustrate this, we're going to use an example project. In this example, we have a stock piece of material positioned in the XY plane, which we want to cut 2 circles from. Here's the concept. Now we'll define a datum using the tools in the CAD/CAM software. In this example, we'll position our datum to be at the bottom left corner of the stock material on the top surface. Once the datum has been set and the project has been fully defined, we'll export the job into a file. Now let's have a look at SmartBench's working datum. Here the yellow box represents SmartBench's working volume or workspace. SmartBench can set its working datum anywhere within this workspace. SmartBench sets its working datum in 2 stages. Firstly in the XY plane and then in the Z axis. Looking at the XY plane, we can see that when a job file is loaded, SmartBench positions the job file to align the job file datum with SmartBench's working datum. SmartBench's working datum can now move anywhere within the workspace and the job file will follow. Be careful to position SmartBench's working datum such that the job file lands completely inside SmartBench's workspace. Let's have a look at SmartBench's working datum in the Z axis now. Looking at the end view of SmartBench, we can see the height of SmartBench's potential workspace and the height position of SmartBench's working datum. We can see how when the job file is loaded, SmartBench again positions the job file to align the job file's datum with SmartBench's working datum. Now I can position my job file to be high enough to include the thickness of a spoil board, or put the job file directly on the machine bed. But again, being careful not to position my working datum such that the job file would cut outside SmartBench's workspace. That's most of the concept behind positioning jobs using datums. There are a few extra bits you should know. You can reposition SmartBench's working datum as many times as you like until your job file is positioned in the right place. However, datums within the exported job files cannot be changed. These remain fixed and can only be changed by going back into the CAD/CAM software, redefining and re-exporting. Note that you cannot rotate the job file on SmartBench, so you have to design it along the axes which SmartBench uses specifically the XY axes. The X-axis of the job will be parallel to the beam and the Y-axis will be parallel to the bench. And finally, Datums gets saved, so your setup won't get lost between power cycles. The job file Datums will live safely in the job files, and SmartBench saves its working datum in the Z-head electronics. So let's try to create our example project in some real-world CAD/CAM software. We'll use Vectric, and in this video we'll focus solely on defining our datums. We'll create a new file and immediately get presented with job setup, which is where we define our datums. In the XY plane, we get a choice of any four corners of the job or the center of the job. In our case, we want bottom left. And then for the Z-axis datum, we get a choice between the machine bed, which is the bottom surface of the material, or the material surface, which is the top surface of the stock. You'll have seen as we've set the X, Y, and Z datums that we've had different options available to us. And each one of these options comes with its own pros and cons. We'll go through these pros and cons at the end of the video. But for now, let's agree to these settings and see what our datums will look like in our job file. Now let's set our job size in X and Y to reflect the area of our stock. It's important to remember that we can't rotate our job file's axes on SmartBench. So the orientation that we set here is the orientation it will get cut on SmartBench. The X-axis runs along the beam and the Y-axis will run along the bench. Finally, we set the thickness of our stock material, which will always be in the Z-axis, before clicking OK to save our settings for our job setup. Our white space now reflects our stock size, and you'll notice that where we set our XY datum in the bottom left-hand corner, that the rulers now have a 0 value at that location. That reflects our datum position in the XY. And to illustrate this, if we changed our XY datum to be in the center of the stock, we would see that our rulers change accordingly so that the 0 positions again line up with our datum. And you'll notice some crosshairs which help as a useful indicator. Let's restore that now by going to Edit, Job Size and Position, and putting the XY datum back to the bottom left position. Now it's time to detail our project. Since this video is only about datums, we'll fast forward through setting our features and toolpaths. If you want to learn how to do this, please visit our knowledge base where you'll find tutorials. We'll leave a link in the description. But for now, we want to draw 2 circles in our stock and define some cut paths along those features. If we look at the 3D model, we can now clearly see our toolpaths. And if we edit our job setup, we can clearly see that these toolpaths are originating from our job file datum, which is on the top surface at the bottom left corner of our stock. Let's do a quick simulation to make sure that the cut file is what we expect. When we're happy that everything's correct, we'll save our job file and transfer it to SmartBench using our SmartTransfer app, which will send the file over the Wi-Fi network to arrive on SmartBench. Again, if you'd like to learn more about transferring files to SmartBench, check out our knowledge base. We'll leave a link in the description below. Welcome back to the real world. So we've prepared our job file around the idea of using this piece of stock. So before we do any alignment or moving of SmartBench's working datum, we're going to position the stock onto SmartBench. Now, I've fastened my stock down to SmartBench, but I'm going to skip how that was done. If you want to learn more about basic work holding, please check out our video on that, which gives a really good description as to how this stock's been fixed to SmartBench. So, you remember from our job file that we've set our job file datum to be in the bottom left corner on the top surface of our stock. So our next job is to tell SmartBench that that's where its working datum needs to be. We do this in the XY plane and then the Z axis. So we'll look at setting it in the XY plane first. We're going to do all of our movements in the Pro app. And we'll be using these buttons here to navigate the Z head around to be able to set our XY datum. And we've got a couple of options. We can either use the laser datum or the tool center. So first of all, we'll cover using the laser datum. I'm going to move now the Z head such that the laser datum crosshair aligns perfectly with the bottom left corner of my stock. To do this, I'm just using the manual move buttons. I'm going quickly on the rabbit setting there just to get into an approximate location. Then I'll go to the turtle mode, which just slows it down a little bit. And I want to now move to 1mm increments to zone in on that corner. And then 0.1mm increments to fine tune it and get really good alignment. Now that I'm happy that the laser crosshair is in exactly the right place, I'm going to push the set button. This sets SmartBench's working datum in the X and Y plane to exactly this location. I'll push the set button now and it will ask, are you using the laser datum? I am, so I'm making sure that that box is ticked. I'm going to confirm by pushing yes now. And when I do, because I'm using the laser datum, SmartBench will automatically move the Z head so that the tool center is over the exact position of the working datum location. This is really just a visual check to make sure that the Z head will start from the position I expect it to. So I've set the working datum in the XY plane. In the previous example, we used the laser, but it's also possible to use the tool center. We're going to go and do this now by quickly manually moving the tool center to the location. To do this, we'll move the Z head around again, but because we need to see the tool while we're setting, we're going to drop the spindle down by lowering the Z axis until we can see the location of the tool. And then it's a bit easier to navigate that tool center to our desired location. When we're happy with the position, then we go ahead and press set again, but this time we uncheck the laser datum box before hitting yes. You'll notice that the Z head doesn't move, but that's because the tool center is already in the correct location. And another note, and this is really a bit advanced, but we've only talked about setting X and Y simultaneously, and it is possible to set X individually and Y individually. To do this, once you've finished navigating the Z head into the right place, you can set the working datum's position in just the X axis or just the Y axis. If I push on set Y, then it'll ask me, do I want to set my datum in just Y? I can again either just use the laser or the tool center with this box and then confirm by pushing yes. Now that we've set SmartBench's working datum in the XY plane, we can see where that is on the console. If we look in the Pro app on the Map tab, we'll be able to see that SmartBench's working datum in the XY plane is represented by the target. It's important to note that we can now move our Z head around the whole of SmartBench and we won't lose that datum position. And at any time we want to come back to that datum position, all we've got to do is press the Go to Datum button and the Z head will return back to that position. Also, you don't need to return it back to that datum to start a job to make sure it starts there. SmartBench will automatically know that when it starts a job, it will begin from the working datum. And finally, we can see the footprint of the job file on the map screen when it's loaded. So let's do that now. So I'll go to the file opening dialog, find our Datums file, and then open that up. And now when I go to the map screen, I can see a red box, and that red box represents the job file's footprint. And we can see how that's extending out away from SmartBench's working datum. This is a really good way to just make sure that your job file is going to be within SmartBench's workspace. Now it's time to set SmartBench's working datum in the Z-axis. What we're trying to do here is we're trying to get the end of the tool to be at the same height as the job file's datum. To get your tooltip to be at that right height, you've got two options. You can either manually eyeball the position of the tool and then set it from what you see, or you can use the Pro plate, which will detect when the tool touches at the right height. In this example, we've set the job file's datum to be at the top surface of the stock. So let's now use the Pro plate to set SmartBench's working datum to be on the top surface of the stock. I'll navigate the Z head over the top surface of the stock. I'll pull out the Pro plate and insert the Pro plate underneath the center of the tool. And I will position the tool to be a few millimeters above the Pro plate. When it's close enough, I'll then press the Z0 Pro button, and you'll see the tool automatically lower towards the Pro plate. On registration, you'll see the dust shoe flash green, telling you that it's saved its working datum. A couple of notes when using the Pro plate. You'll notice that I didn't do it at the XY coordinates where there's only a corner to put the Pro plate on. I moved the Z head over, and that's so that I could get a solid contact patch with the Pro plate. And that's okay because the whole top surface of that stock represents the height at which the job datum is at. And the second thing is to make sure that the area is void of any chips or dust that might artificially lift that Pro plate and give a wrong Z height. Similarly, make sure when you're pushing the Pro plate underneath the dust shoe, give an amount of pressure which will make sure that it's sitting flatly on the top surface of the material and not giving an artificially high reading. The alternative to using the Z height Pro plate is to set it manually. And you might need to do this if you're in an application where you don't have much of a contact patch for your Pro plate to sit. In this instance, you would drive the tooltip down manually, and when you can see that it's at the right height, you press the set button and SmartBench will position its working datum at that height. Let's do that now. I've moved my Z head over the top surface of the stock material, and now I'm going to lower the tool. As I get closer to the top surface, I'm going to move to 0.1 millimeter increments. And just watch until that tool just kisses the top surface of the material. When I'm happy that's the case, I'll then just push the set button. And that means that SmartBench will have set its working datum to that height. Now we've set our Z-axis, it's the same behavior as with the XY. We can still move our Z-axis around, and SmartBench will remember where the working datum is. So it can return back to that datum at any time, and the axis can be in any position before we start the job. SmartBench will still return to that working datum before it starts the job. In the manual move screen, if you want to return to SmartBench's working datum in the Z-axis, all you've got to do is push the Go to Z0 button. Just like with the XY datum, we can visually see how the job's going to look in the Z-axis by looking at the screen. You'll see two color zones, a yellow zone and a red zone. And the Z datum is actually at the point where the yellow zone meets the red zone. Now you might wonder what those different colors mean, and it's pretty simple. The yellow zone is any movement in the z-axis in the job file which is above the datum, and the red zone is any movement in the job file which is below the datum. Now, in the example we've just been through, we put the job file's datum in the bottom left corner and on the top surface. But that's not the only place we could have put that datum. So let's just have a look at some of the different options that we've got available to us and some of those pros and cons. The bottom left corner that we used is actually a very common datum point, and it's useful because it's close to our home position, but also that we can get a good visual representation as to what the total footprint of the job file will be. One downside with it though is if you're into precision work, you need to make sure that this corner is sharp so that it gives you a nice reference point to datum from. Alternatively, you could put the job file datum in the center of the stock, and that can be useful if you're cutting a sign where you want that detail to be symmetrical to the stock that you have available. Similarly, it can also be useful if you don't actually have a corner to reference on. It just depends on the stock that you're cutting from. Now let's look at the options in the z-axis. So you've got two options when setting the datum in the z-axis for your job file datum, either the top of the stock or the bottom of the stock. The top surface is the most common, and that's because it's easy to access. I can easily get a probe plate to touch this. Also, it's fantastic if you're engraving, because you're making sure that the depth of that engraved cut is relative to the top surface of the material, which is what you care about. But one of the downsides of referencing the top is that if you have any variation in your material thickness, you don't actually know where the bottom of your final cut depth will be. And so for that reason, if you need to be super accurate in your final cutting depth, it's best to reference the bottom of your stock. The main reason though that that's not popular is because it's just a bit more difficult to access. So it's horses for courses, and really you need to pick whatever is best for your application. So that's datums. If you're new to CNC, it's quite a lot to take in, but as you start using them, you'll quickly see how fast and efficient they are at setting your jobs up and getting things in the right place. And you'll start to understand why the whole of the CNC technology relies on datum technology. Thanks a lot for watching. I hope it's been useful. We'll see you in the next one.